Okay, so these are going to be the solutions to the second practice test. So I strongly encourage people to work through this before they look at the solutions, but if you're stuck, that's okay. So problems 1 through 5, the first 5 problems, these will be the first 5 problems on the test, right? These are memorization things you really need to know when you leave this class. So fill out this table. Sine starts at 0, goes to 1/2, goes to square root of 2 over 2, goes to square root of 3 over 2. I don't know why my tablet is acting weird. And then ends at 1. So sine increases from 0 up to 1 as the angle goes from 0 to 90. Cosine decreases, so 1 square root of 3 over 2, root 2 over 2, and then 1/2. And then it goes down to 0. Tangent is sine divided by cosine. So 0 divided by 1 is 0. 1/2 divided by 1 over the square root of 3. Well, the 2's cancel out, so you get 1 over square root of 3. These are the same. So it's 1 square root of 3 over 2 divided by 1 over 2. Well, the 2's cancel out. You get a square root of 3. And then 1 divided by 0 is undefined. Okay, formulas for these two things. Sine 2x is 2 sine x cosine x. Cosine 2x is cosine squared x minus sine squared x. Okay, sine of a plus or minus b, cosine a plus or minus b. This is really 4 formulas. Sine of a plus b is sine of a cosine of b plus cosine of a sine of b. And notice that if a and b are the same, then you get this formula. It'd be sine a cosine a plus cosine a sine a. It'd be the same thing repeated. Sine of a minus b is the same thing, except for minus sign there. Cosine of a plus b is cosine a cosine b minus sine a sine b. And notice if a and b are both equal to x, you get cosine squared x, that's this, minus sine squared x. So that's this formula. And then cosine a minus b is the same formula, except the sign changes in the middle. We have an addition there. So law of sines, including the triangle. What does it mean by a triangle? Well, the law of sines refers to a particular triangle, right? And it's sort of a generic triangle that looks more or less like this. This is the angle A. This is the side length A, B, B, C, C. Capital letters are angles. Small letters are sides. So A over sine A equals B over sine B equals C over sine C. You can also write this with the signs on top and the smaller numbers on the bottom. That's fine. Law of cosines, same triangle. Angle A. Oops, sorry about that. Don't know what the heck was going on there. We'll just clear some of that out. So angle A, side length A, B, B, angle C, side length C. And so a squared equals c squared plus b squared minus 2cb cosine A. So the sine A and the cosine A and the angle A here and here sort of on opposite sides, and then the two sides adjacent to the angle A show up here and here. So there's actually three different versions depending on which side length you want to have. You could write it as b squared. So b squared equals, well, take the square of the other two sides, a squared plus c squared minus 2ac times the cosine of the angle opposite the side, b. And the last one would be a squared plus b squared minus 2ab cosine c. Any one of those three is fine. You don't need to write down all three of them, just any one of them. So those, bunch of stuff that you really should have memorized. Those will be the first 5 problems on the test. So let's see. Oh, didn't want to go that far. What is sine of a plus b, given that a and b are both angles in the first quadrant, and sine of a is this and sine of b is that? Well, we can rewrite this using the formula we just wrote down. Now, I have no idea what the angles are. I mean, you could find out what they are if you wanted, but we don't need that to answer this question. Sine A, cosine B, cosine A, sine B. Now, we know what this is. It's 4/5. And we know what sine B is. That's 12 over 13. What I don't know is what's cosine B and what's cosine A. But I can find them. Because remember, SOHCAHTOA, sine is opposite over hypotenuse. So if I take this, I can draw a triangle, right triangle with A there. Opposite over hypotenuse means the 4 is my opposite and the 5 is my hypotenuse. And then I can find this side. This is adjacent, because I know adjacent squared plus 4 squared must be equal to 5 squared. Adjacent squared plus 16 equals 25. So adjacent squared equals 9, or adjacent equals 3. And that's nice because now I know what cosine of A is. Cosine is adjacent over hypotenuse. So cosine of A is, let me undo that real quick. Cosine of A is 3 over 5. Great. And we can find cosine of B the same way. We can draw a triangle. We'll put in the angle B. We'll put in the right angle. We know sine of B is 12 over 13. That means this is 13. This is 12. And so this is adjacent. Adjacent squared plus 12 squared equals 13 squared. So adjacent squared plus 144 equals 169. Subtract the 144 from both sides. And so we get the adjacent is 5. So that means the cosine of B is 5 over 13. You can, if you really wanted, to pull this all together. I would be absolutely, on a test, just end at this point. You don't need to pull this together, but you could if you wanted. We'd write this as 20 over 65 plus 36 over 65 equals 56 over 65, if you wanted to. But this answer here is just fine. So remember, if you know the sine of a triangle, you can always find the cosine and the other trig functions. So find cosine of A minus B, given that A is an angle in the second quadrant with sine of A equals 3/5, and B is an angle in the third quadrant with cosine B equals minus 5 over 13. So we need the formula for cosine A minus B, and that's equals cosine A, cosine B, plus, because it's a minus and you change the sign, sine A, sine B. And let's see, sine A we know is 3/5. Cosine B we know is minus 5/13. And what we need to know are what's cosine of A and what's sine of B. So cosine of A, well, sine of A is 3/5. And this is the same triangle we had above, so it's going to be 4. So cosine of A is 4/5, but you have to remember that A is an angle in the second quadrant. So if we think about ourselves in terms of the unit circle, what we've got is a triangle like this, where this is 5, this length is 3, which means as an x-coordinates -3. No, this length is 3. Let me slow down a little bit. This length is 4, but the x-coordinate is -4, and then this is 3. So the cosine that we're looking for is -4/5 because A is an angle that's in the second quadrant. What about sine of B? Well, same kind of thing, right? B is an angle in the third quadrant, so we can build a triangle. Here's angle B. Cosine of B is 5/13. This is supposed to be a B here. And that means this other side is 12. It's the same triangle that we had above. But when we think about this as being in the unit circle, it's a triangle that's actually down here, right? And so the coordinate of this point is going to be the x-coordinate is -5/13, and the y-coordinate is -12/13. So what's the sine of B? The sine of B is 12/13, but because B is an angle in the third quadrant and sine is negative in the third quadrant, that means that's going to be a negative 12/13. And again, you can multiply this out if you wanted. You could stop right here. That's a perfect, good example, good solution. But if you really want to know what the numbers turn out to be, it's -16/65. Okay, and you don't need to know what the angles A and B are to be able to solve this problem. So find all the solutions to sine of 2x equals 1/√2. Well, remember our unit circle. If y equals 1/√2, which is the same thing as square root of 2/2, then there's two angles that give me that. One is 45 degrees. So I'm going to do this in degrees instead of in radians. And the other is 135 degrees. So there's always two angles. If you have a particular sign, there's always two angles that give you that sign. So if I take a sine of something, an unknown thing, equal to 1/√2, that means that my unknown thing has to be either 45 degrees or 135 degrees. But you have to keep in mind that you can always go around the circle and you end up at the same place with the same coordinate, right? Or you go around the circle twice or 3 times. Or you can go backwards around the circle. So there's actually infinitely many solutions based on 45 and 135. In this problem, what is my unknown? My unknown is the 2x. So we'll replace the 2x wherever I have unknown, and I get 2x equals 45 degrees plus 360 degrees times n, where n can be any integer. And the second grouping is that. Oop, that's a degree sign. And so if I solve this for x, that means just divide everything by 2. And same thing here, half of 135 is 67.5 degrees plus 180. Right? So the idea here is we can solve the equation. If we know what the sign is, we can get the unknown equation. And then we have two solutions, 45 degrees and 135. And note that these two add up to 180 degrees. So we get these two infinite families. And then you say, okay, well, my unknown here is 2x. So you plug that in and just divide through by 2 to solve for x. So why are there no solutions to this triangle? How do you go about explaining this? Well, this is a law of sines problem. Right? And anytime you see something like this, that tells you we're dealing with the law of sines. So the only side length you know besides A is B. So we know A over sine A is about, I'm just going to call it 53. But that means that B over sine B also has to be equal to that. So what does that tell me about sine B? Sine of B has to be equal to length of B over 53, right? So if I solve this equation for sine of B, I get this. But I know that B is 71. So that tells me the sine of the angle B has to be 71 over 53, but 71 over 53 is greater than 1. So there is no solution for sine B equals 71 over 53. Right? There's no possible angle B that we could use. So there's no solutions to this triangle. This is, the argument here is in the same direction. Why are there two solutions to the following triangle? Well, again, a law of sines kind of thing here. A over sine A is about 84. So that means we know what length B is. That means length B over sine B is about 84. So 62 over sine of B equals 84, because that's B is equal to 62. So solving this equation for sine B gives me 62 over 84. And remember what we were saying above, if you take the unit circle and you take a particular y value, say y equals 62 over 84, and that's less than 1. So it's, right, remember the top of the unit circle is 1. So in here somewhere there's a y value. How many solutions are there to sine of something equals 62 over 84? Well, there's two angles. There's this one and there's this one. So this equation has two solutions, which is why there are two solutions to the following triangle. So given this particular setup, what's the length of A? Well, if you think about this in terms of triangles, what you've got is you've got a side length, an angle A, side length A, and two sides, B equals 20 and C equals 30. And we know that this is 60 degrees. So this is set up for the law of cosines, which you stated up above. So that means A squared equals B squared. B is 20, not 30. Plus C squared minus 2AB. Nope. Undo that. 2BC cosine of A. Great. So A squared is what? It's going to be B squared, which is 20 squared, plus C squared, which is 30 squared, minus 2 times 20 times 30 times cosine of 60 degrees. Right? And cosine of 60 degrees, oops, we're there. If you want to go there, then I want to scroll up. Cosine of 60 degrees is way up here in this table. Cosine of 60 degrees is 1/2. Where are we? We're way down here. So a squared is equal to, well, 2 times 2 is 4. 10 squared is 100. So this is 4 times 100, 400 plus 900. 2 times 20 is 40 times 30 is going to be 1200 times 1/2, because cosine of 60 is 1/2. So a squared equals 1300 minus 600 equals 700. So a equals square root of 700. So that's the law of cosines problem, because you know an angle in the two adjacent sides and you're asked for the third one. So plot these 4 points in polar coordinates. Remember that theta is the angle up from the positive x-axis and r is your radius. So problem A, you go up to 45 degrees and you go out 1 unit. So there's where A would be. B, you go to 210 degrees. So 180 is out here. 210 degrees is about here. And you go 2 units in that direction. So that'd be about out here. So there's our point B. R equals -1, theta equals 30 degrees. So you go out to 30 degrees, which is here. And notice that 30 degrees plus 180 degrees is 210. So these two sort of the same line. -1 means instead of going out in this direction, that would be the positive R direction, you go in the negative R direction, which is back this way. So point C is here. R equals 3, theta equals 360. This is more than 630, more than 360 degrees. So I want to subtract off a 360 from that. Usually I do this by counting backwards, right? So if we add 40 to 360, you get 400 plus another 20 gives you 240 plus another 30. That would mean 270, right? 0, 13, and 3 plus, yep. So 270 and 270 degrees. Well, this is 90. This is 180. This is 270. So 630 degrees is around the circle once, and then another 270 degrees, and you go 3 units in that direction, and that gives you point D. So how do we sketch this graph? Well, we need to think a little bit about what sine does, right? And if we go back up to the question, we had to write down the sine values. We know that if the angles we're putting into sine are 0, 30, 60. Well, actually, there's a couple different ways to explain this, so I'm going to use a different way to do this. So let me undo this. Boop. Okay, so a different way to explain this. Sine 2 theta, we know this is 2 cycles in 2 pi, because it's a 2 theta. So here's 2 pi, here's pi. We do a cycle from 0 to pi, and then we do a cycle from 0 to 2 pi. And this is pi over 2, and this is 3 pi over 2. So if we think of the quadrants, right, this is angle 0, this is angle pi over 2. So sine of 2 theta, which is this graph here, as the angle goes from 0 to pi over 2, sine goes from 0 up to 1, and then back down to 0. And this is halfway, so that's pi over 4. So what does that mean for our graph? We start at 0 and our radius goes out to 1 at pi over 4. And then when you come back down to pi over 2, it's come back down to 0. From pi over 2 to pi, that's the second quadrant, our sign starts at 0, goes down to -1, and then comes back up. So it's negative. And remember that if we have an angle between pi over 2 and pi, the positive r direction is this way, but the negative r direction is that way. And we're dealing with negative r's here. So we're going to go from 0 down to -1 and then back up to 0. So instead of doing the second quadrant, we're actually going to be graphing it in the fourth quadrant. So this point here is theta equals 3 pi over 4 and r equals -1. And that corresponds to that value on this sine 2 theta graph. Then when we get to pi to 3 pi over 2 in the third quadrant, that's from here to here, we're positive again. We go from 0 up to 1 and then back down. So we go from 0 up and back down. And again, this is at 3 pi over 4 is where our maximums are. And then finally, from 3 pi over 2 to 2 pi, that's this quadrant, the fourth quadrant, we have negative r's, right? R is between, starts at 0, goes down to -1 and back up. So instead of plotting something in the fourth quadrant, we actually end up plotting it in the second quadrant. And so this is the point, this point is theta equals 7 pi over 4, right? So 7 pi over 4 is there, but r equals -1. So instead of plotting 7 pi over 4 here, we actually plot it out there. So this part of the sine 2 theta graph is this part of the polar graph. This part is this part, and then this part, and this part of the last two. Okay, vector addition. Just add the components, right? This is just addition. So you get 2 I hat minus 2 I hat minus 3 j hat plus 5 j hat. And that's 2 minus 2 times I hat, if I factor out an I hat of that, plus minus 3 plus 5 minus 3. Oh my God, my handwriting sucks. Okay, let's undo some of this so we can actually read it. Plus minus 3 plus 5 j hat, right? Because we just factor out the j hat there. 2 minus 2 is 0, so we can ignore that. Minus 3 plus 5 is 2, so it's 2 j hat. 2 v hat, that just means take your vectors and multiply through by distributing your 2 minus 6 j hat. Okay, finally, for the length of a vector, give myself a little space here. This is the length of the vector w. Keep in mind that the vector w is minus 2 I hat. I hat means in the x direction. So your x coordinate is minus 2. Y coordinate is 5. So it's a vector like that. And all we want is what's the length of this side. So you can always just draw it as a right triangle. One side is 5, one side is 2. So technically it's going to be minus 2 quantity squared plus 5 squared square root, because that's our Pythagorean theorem. That's square root of 4 plus 25, square root of 29. So dot product, what's the formula for a dot product? dot product means just multiply the coefficients of the corresponding things. So v dot w is 2 times minus 2, because that's the coefficients of I, minus, well, we'll do it as a plus, minus 3 times 5. So you take the x coefficients, the 2 times minus 2, and then take the y coefficients, the minus 3 times 5, and then add them together. So this is minus 4 minus 15, which is minus 3. So the test will be very similar to this, but there'll be, different numbers and things, but pretty much along these lines. So if you're okay with this, you should be pretty good for the test. Remember that these first 5 problems are going to be the same ones. It's just some memorization. So make sure that you get those things memorized.